When testing two population means, it is critical to know how to treat the standard deviation in your samples or in your populations. So you may have populations where the theoretical standard deviations are given, but you may also face the fact that they are not given as theoretical values and they may or may not be assumed to be equal. So there are three types of tests that cover those different instances. The first one is the test for unknown and unequal variances. So if you're just given two samples and you don't have any prior information about the variance in the two populations, and even more, maybe from the look of the variances, you can't assume equality between them, so you should use this test. And we use here T procedure. So the standard error for this T procedure looks like what we have given in the introduction, and it's basically square root of rescaled variances. Now, T procedure also needs the number of degrees of freedom, and in this particular test we have it given by this big formula, but luckily this formula is still very straightforward because the variances are given and the sample sizes are given. So all we have to do is plug the numbers in and get the number out. The T statistic for null hypothesis such that the difference between the two population means equals delta looks like this. So we are taking the difference between these two and we are making the difference with the theoretical distance between them, marked as delta, and then we divide it by the standard error. So in overall, the formula looks like this. We might be testing for this difference to be the other way, so that maybe mu b minus mu a equals delta, so that maybe there is an increase in the population value when compared to the other one. But that really depends on the task, so you have to be aware of that when you write down your formula in here. And that, of course, if we had mu b minus mu a, that would mean that the sample means here would be the other way. And now the decision for the test. Well, if we consider confidence level alpha and we consider two-sided test, which is in this case, because since we're testing that difference is delta, but it can be somewhere just a little bit on the left from our delta, or it can be on the right. So that means that we have to give half and half of the probability to each of the sides. So that's why we consider the absolute value of our T statistic and we compare it with the critical T value on either side, or with the absolute value. So then colloquially, we could actually say that hypothesis test accepts null hypothesis if this is true. Now, if you were talking to a very strict statistician, they would shout and say that you can't say that you accept null, you rather fail to reject. In this course, you can use either of these expressions, but be aware that some people may complain. And then we do reject null hypothesis if the absolute value of our statistic is far enough from the critical value. So in other words, far enough from zero, basically. And as T distribution is symmetric and it looks like normal, so indeed, if we are within the region that the T statistic is statistically considered to be close to zero, then we would be failing to reject null. And if it's far enough, so it's somewhere on the left or right of the critical values, then we can say that we reject null.